Hi, today we're going to be talking more about transformations of a single variable. We've seen previously the transformation y equals x squared, but now I've changed the distribution of x. X is exponentially distributed with mean of 2. We need to determine the density function of y and the values of y for which the density is non-zero. We're going to follow the same procedure as before, and we're going to start with the cumulative of y. Cumulative of y, that is g of y, and it by definition is the probability y is less than or equal to little y. We can replace the distribution, we can replace the random variable of y with its transformation, that's x squared, being less than or equal to y. And as we saw last time, this will be the probability of minus y being less than x and being less than the square root of positive y. Well, now we're ready to calculate probabilities with the density function of x. So it'll look something like this. But now you'll ask yourself, what's the density function of x? Oh yeah, we're told x is exponential with mean of 2. So f of x is going to be 1 over beta times e to the minus x over beta for x greater than 0. And here beta is equal to 2 because it's specified in the problem. Okay, so we can use this. So this will be 1/2 times e to the minus x over 2 dx. It says x has to be greater than 0, so the lower limit of integration is not negative square root of y, it's 0. 2 square root of y. And now we anti-differentiate this. This will be minus e to the minus x over 2, evaluated at 0, and root y. Now, if you're not sure how we got that antiderivative, you can just do a u substitution with u equal to minus x over 2. So plugging in the limits of integration, minus e to the minus root y over 2 plus e to the 0, which is 1. And this is g of y, the density, the cumulative of y. If we want the density, we have to take the derivative. G prime of y is equal to the derivative of y of 1 minus e to the minus root y over 2. Now we take the derivative, the first term's 0, the second term, well, it uses the chain rule, so it is itself minus root y over 2 times the derivative of what's inside. The derivative of what's inside, well, we have to differentiate minus y to the 1/2 over 2. So this is going to be minus 1 over 4 root y. And when we clean that up, this will be 1 over 4 root y times e to the minus root y over 2. Okay, great. We have the density. When does it apply? Well, let's look at the graph here. Here's y equals x squared. And we're told that the density function of x is for x greater than 0. So 0 onward, which would correspond to those y values. So it looks like y is just going to be greater than 0 here. Okay. Thank you very much.